Hello there.
Yeah.
All right. Cool. So, just double checking before we start. You
Yeah,
are here for system design interview for Meta, right?
that's right. Yeah.
Okay. And you are sure that you are looking for system design and not product design?
Yes. System design for an engineering manager. Engineering manager is the role that I'm currently doing. Yeah.
Okay. Engineering manager. Okay. Cool. And what level are you targeting?
M1.
Okay. Cool. Sounds quite straightforward. So M1 is gonna be have the bar for M1 is gonna be between L5 and L6.
Mm-hmm.
So I am going to adjust the interview to that level. And before we start, I'm just gonna be conducting a normal meta mock interview, and I'm going to give you a feedback in the last couple of minutes. Is this something that align with what you are expecting, or do you have other things in mind?
Oh no, it's pretty much the same thing. It's like for an M1, if it's like an L5, L6, then that's perfect. That's the expectation from my end as well.
Okay, cool. So the interview at Meta is typically 45 minutes, right? But really, the first and then last 5 minutes is just Q&A. So the real interview itself is actually just technical, just 35 minutes.
Got it.
So let's try to actually simulate that experience. So you can also reflect your timekeeping and time management correctly. So now it's 02. Let's try to finish by 37 and use the remaining time for feedback. Sounds good to you?
Yeah, that sounds good.
Okay. A question that can go between L5 and L6. Okay, I'll give you this. Actually, let's draw something in the whiteboard. So, are you okay? I can see you here. So let's say this is like a mobile app of Facebook, right? And you have some content here, some content either video, photo, whatever, right? Time to time you will see comments below that photo. Bah. Okay, whatever. Comment 1, comment 2. So the interesting thing happen if you are just staring at the screen, right? Not doing anything, just looking at the screen, enjoying the video or the photo, and then sometimes you will see somebody is typing.
Mm-hmm.
And then somebody's typing gets resolved into a new comment, like comment 3.
Mm-hmm.
So this new comment is what we call that appears out of nowhere, right? You don't pull to refresh, you don't do anything, you're just enjoying your photo and enjoying your type, right? But suddenly it shows up out of nowhere. We call it live comment.
Got it.
So please design me live comment.
All right. So we have pretty much the feature build that is being asked for is like a live comment feature.
Yeah, the live comment feature. Yeah.
All right. I'm switching back to the text just so that I can walk through what the functional and non-functional requirements are. Functional requirements. From this end, a quick couple of questions from my end would be just to clarify the scope. When the comments show up, should we do any sort of filtering? What I mean by this is that
yes, go ahead.
basically
Sorry, go ahead. What do you mean by filtering?
So filtering here pretty much means that do we need to look at the text and censored words or anything along those lines, or is this just like comment as is, we're just posting it?
No, I don't think so. I don't think you need filtering.
I would say it's basically along the lines of like privacy, security, anything along those lines, but the short answer seems to be no. Right.
No, I don't think so. It's out of scope of this project. No.
All right, perfect. And do we allow people to update the comment or delete the live comment?
No, nope.
Okay, it just creates and delete.
Yep.
All right. I think it's clear. I think the other questions that I had were, is the comment just text-based or to support media, like uploading photos, video?
Photo, media. I want to cover that, but I don't think that's important right now.
All right. Okay. Just text-based for now. Right. Good time check. There's still. I'll just use 1 more minute to ask one more question over here. I think. All right. No text. No this thing. Is reaction to the comment in scope? So what I mean by this is like, yeah, as it's pretty straightforward.
Yeah, I see what you mean, but no.
All right. All right. I think this makes things very clear. The only thing that we have to worry about is like creating and reading the comments. There's no filtering, so there's no like processing involved. It's just text-based for now. There's no reactions that we have to do for like the common set of features. I think apart from that, did I have any other questions for functional requirements? Yeah, no, I think this makes at least the functionality very clear in terms of what we need to do. And
okay.
I'll just move on to the non-functional requirements part.
Wait, before we go, you basically list me like what it is not. You haven't told me what it is.
Sorry?
Here, you basically listed what it is not. You haven't told me what it is. What is in the scope? What is in functional requirement? You mentioned what is not in the scope. This all here, like all 4, is basically what's not in the scope.
Yes. So what is in scope is, this is what I've understood from what is in scope is creating and reading comments. Second one is support for text-based comments. Third one is basically along the lines of like ordering comments by time. Based on like what time is posted, we just ensure that those comments come in over here. And the fourth one is, I think you also mentioned this, is where someone is typing. That is in scope as well. So these are the 4 main things that I've seen based on like what is in scope, based on like what you mentioned in like the diagrammatic representation, and also just based on like the scope questions that I asked before. Is there anything else that I'm missing?
Yeah, I think that looks straightforward. Yeah, that sounds about right. Mm-hmm.
Oh, perfect. Okay. Right. I'll move to the non-functional requirements. Basically here, the questions that I'm going to ask is,
Okay.
videos.
Based on your knowledge about Facebook, like how much do you think will be the number of people that will write the videos or photos?
So the average number, basically what I'm getting at is excluding celebrities and for like celebrity personalities, an average photo would get around like, I would say at least a maximum of like 25 to 30 comments. That's pretty much like how I'm thinking about this. And this would pretty much mean that if I'm translating this to like Facebook scale, you have 1 billion users. And even if you assume that like 1% of these users comment on a post, that would translate this to, I would say, 10 million. And if that is the case, then you have 10 million people that are average commenting like twice or thrice, or I would say 4 comments per person. You're looking at like 40 million comments per day. That's pretty much like, I mean, these are assumption numbers that I'm making, but does this on average look reasonable in terms of like how many live comments would we expect to be written at any given point in time per day? And this is globally and excluding spikes due to celebrities.
Okay, nice. Good call out on like thinking about celebrities. Sure, this seems like a good number.
All right. Okay.
No, this is like a good number assumption. Sure.
I'm sorry.
This seems like a good number assumption.
All right.
What else?
I think after this is where we would go into, sorry, let me just quickly think about this. So you would have 40 million comments. Is there anything else that I'm missing? With this kind of a thing, now you can go for 2 particular events, which is either like high consistency or high availability trade-off.
Okay.
Now, with a live comments feature, like one of the things that we could definitely think about is like having a more high availability with eventual consistency as like the goal that we could go for, mainly to ensure that when I'm reading a comment versus like person A reading comment would see 10, while person B would see 15, and eventually the information becomes consistent. Like that product experience would be better, at least in my the way that I'm thinking about this is like having the ability for a person to see all the comments and then eventually catching up to like consistency across like different set of users would be a better experience versus like enforcing consistency, because as soon as someone loads a photo, it's better experience to just show the comments as much as possible.
sounds fine.
Right.
Sounds right.
Yeah. And pretty much what this also means is that if you look at like the quorum calculations, would be lower, which basically means that the number of machines that give us like consistent information, like for example, like closest machine, we can just be like within our system diagram. If we say there are like 4 or 5 replicas, and if just one of the replicas returns us the information, we just like say, okay, this is what we're going to show, rather than doing a quorum calculation of like, okay, give me responses from like 4 different servers, seeing if they are consistent, and if they're not consistent, not returning anything like that. It's pretty much a translation of like what this means that I wanted to go.
Okay.
All right. So this is with non-functional requirements. You have like the trade-offs that I've just described and like the number of user calculations. Now, I wanted to go to the high-level design, and this pretty much is like divided into 3 subsections. One is API patterns, and here would be like the 3 main things that I would cover is API pattern, data model, and capacity estimation. Now, keeping time in consideration over here, I'll just go through all of these things very quickly. So here you would have create, post ID equals something, and comment equals this text. That would be the create. And then read comments. Also, I apologize if my keyboard is too loud. I'm trying to like type as softly
No,
as
it's
possible.
fine. I just realized that like I forgot to ask you several things here. There are 2 things that I wanna ask. The first one is the latency requirement, and then second one is like if the comment gonna be persistent on the non-functional requirement.
Okay. I missed asking these 2. Okay. I think from a latency requirement, it goes back to like the availability question in terms of like how quickly do you want to return the information. This should be low latency. And if the comment going to be persistent, yes. And this goes back to like one of the probably functional requirements that I should have asked is replay feature. Like since we're doing like live comments over here, do we want the ability to be like when someone clicks the video all over again and when the live section is done, do you want to reload it in the particular feature? So I would say comments going to be persistent. It should ideally be yes, because you would still like to see the comments. So if it makes sense that there's 2 things, like one, we need to have a persistent storage for the comments feature as well.
Replay feature. I don't get what you mean.
Oh, so replay would be, so if I go to the whiteboard again, so you saw the comment 3 show up as like a live comment. And if I, oh, yes, okay. Sorry. I don't know if the text is not showing up for some reason, but let me just redo this. If I load the same video again, I see the comments loading one by one, as though I was watching the video all over again. That's pretty much what I meant by like the live comment video.
Oh, I see. So it doesn't apply for photo, right? Only for video.
Got it. Okay.
But no, you don't need to do the replay.
Got it. Okay. All right. I think that makes it clear. So comments should persist, but no replay video. And latency requirement is low latency requirement, low latency, right? Latency, consistency, and availability are all taken care of. But yes, sorry, going back to like the high level design, the API patterns are basically like create and update over here. Data model will be, apart from like the major data models that we look for, which is like user level information, post level information. Comments is still a new table that we would like to do. And I'm going with a traditional like relational data model. It's very familiar to me, which is the reason why I'm giving a relational data model. We can of course go for like the non-relational data model as well. But in my case, just to move the conversation very quickly over here, I'm just going to outline like how the comment section is going to look like. You're going to have the ID column, you're going to have the text column, and then you're going to have like post ID, so that like you can see which comment section it was posted by, and user ID, which user posted this. And all of this, if I am looking at this, just to be ensuring that we have enough unique IDs being generated, you would have 64 bits, which means that it takes 8 bytes of storage. Text, if you're allowing for like 50 characters, then you would be 50 bytes. Same thing for post ID and UID as well, which will be 8 bytes each. Time check, I still have only 24 minutes, so 50, 50, 60, 66, 74. I'm going to approximate it to 80 bytes just so that like I have a nice even number that I'm working with. And if I multiply this by 40 million comments that we expect globally per day, then you're looking at like KB, MB, I would say 3.2 GB of storage is pretty much what you're estimating on a daily basis. Excluding multiple weeks. Right. Right. I combine both this and capacity estimation here. All right. Any questions here before I move on to like the high level design?
This one, I'm still not sure about this one. The API for this. Because I assume this is a REST API, right? Is this a REST API? What is this?
Oh, so this is the right API. So this would create the information, create a comment for a given post ID, whereas this is reading the information for a given post ID.
Yeah. So this is REST API or GraphQL or gRPC or?
Oh, this is REST or a simple REST API is pretty much what I'm going with right now.
Okay.
You can have multiple configurations in terms of having GraphQL over here as well. But just for familiarity purposes, I'm just going with REST API right now. You can definitely have implementations in like GraphQL over here. where you define a schema, and then you have a payload that is sent along the lines of like something along these lines that says request response over here. Sorry, just give me 1 second. Query of create that would have something along the lines of like post ID, and then you would have the information that is being returned in terms of like text, users, etc. But that's a more complicated way of like approaching this that I don't think I have enough time to get into, which is the reason why I'm just going with like the simple API patterns, the simple REST API patterns.
Okay, sure. I'm actually like wondering about this particular one, the read perspective, but I will let you explain. It's up to how are you going to explain this.
Oh, sure. So the basic idea here is that given a post ID, we need to get a list of comments. If that is the case, what this API is basically telling us is that go to the read path, and what I want is comments. Or you can do the other route of like read post ID and type equals comments. But the idea behind this is that you have a specific path, and for the path that you provided over here, you get what the post ID is, and then you get like what type of information do you want, which is comments. And each one of this triggers like a function in the server side.
Yes, it makes sense. But I'm just wondering from like the user experience, like, are you going to keep calling to this API to get the newest comment?
Oh, no.
Or like how is it going to?
Yeah. I wanted to tackle that in like the high-level system design in terms of like how I was actually going to.
That's why exactly I said I'm going to let you explain whatever you want, but I just don't think this is the right way to do it.
Oh, okay. So in this case, this would be okay. Let me clarify. This would be in this case either HTTP long pole or a WebSocket connection is pretty much what we would provide over here to get this ongoing set of information. That's pretty much, if your question was around like what type of protocol would I be using, it would be one of these two, which would either be a long pole or a WebSocket. Now, I would prefer a WebSocket connection in this case, mainly because of the fact of like it's bidirectional, so that like not only instead of doing like a separate create comment every time, you can just you can use the same connection and send comments as well. Whereas if you do a long pole with server sent events, it's a perfect way to subscribe for events in terms of like push comments being sent to you. But if you have to send a comment, you will need to send a different like HTTP request for it.
Okay.
Right.
Cool. Sounds good.
All right. I know time check. We are nearly out of time, so I'm just gonna draw out like the basic level diagrams over here.
Okay.
Right. I'm gonna use this as the main thing. I'm just gonna go silent here while I keep drawing like the major block level diagrams. Silent. push service. Then you would have persistent storage.
Okay, interesting.
Common create service layer. And then you have right. This should be it. HQ. Right. Very high level. The way this workflow is going to work is that you have a client over here that is giving a read subscription to like the load balancer. Now, from here, you have a configuration service. Configuration monitoring service over here. Monitoring is basically taking a look at like all the service layer and figuring out like which machines are like performing as expected. The configuration is trying to now figure out, is a layer where it acts as like the source of truth to figure out like which machine is like the closest to the user based on like what the load balancer is asking us. So you would have arrow, come here, this would come here, 1, 2. 2 is basically returning like which machine is the one that is available. What then happens is that this now sends a request to like this particular machine, a single machine that says that, okay, this is the user and this is the video or photo that they want to subscribe to for live events. And what the subscription service now does is like, if there are like a bunch of machines over here, it stores a mapping of user ID to host ID. These set of machines, what they pretty much do is that they help understand like for the WebSocket connection that gets created between like the client machine and this, oh, sorry, not user ID, but rather connection ID. It's basically a way of saying that for each connection, there's a user that has a connection to the user. And for the connection, which is the post that is it's being mapped to. And this is stored locally on the set of machines over here, mainly because of the fact of like, you don't need to persist this information anywhere outside the machine. Because if a machine goes down, the connection with the client also goes down. So the client needs to reestablish the connection all over again. So that particular, you don't need to persist it, which is the reason why you have it locally on the machine. Now, once this is done, this machine now subscribes to what we call as a push service. And what this push service basically does is, sorry, I forgot to do one more thing over here.
I will let you finish.
machine ID to video ID. What the push service basically does is, for any message queue events that are sent from the comment creation service, it pretty much figures out like, okay, this is a new comment that is coming in for this particular like post ID. Now I need to figure out like which is the machine ID that is subscribed to like this particular like event comments for this particular session. So what the push service does is like, it looks like the memory cache over here, figures out which is the machine for which like this comment needs to be pushed for, looks that up, sends the information back to like this particular machine. And now this machine knows like, okay, this is the connection that is interested in this particular post, and pushes the information back. So this bi-directional connection helps in this manner of like, or at least the flow is like, you have the right event from here. The right event goes to this comment creation service. This comment creation service handles all these events and sends it to like this message queue over here. Now, and once this is done, this push service acts like a consumer over here, gets events from here, pushes it back to like that right connection ID. This is a super simple way of like me showing like how the information flows across the board. Now, the reason why I've created a queue over here is that since we do want to persist the comments, there is another service layer over here that pulls these comments that from these message queues and then sends it to the persistent storage so that like you have the list of like all the comments that have occurred for a particular post ID.
So if the message queue dies, the comment dies altogether? Like,
that's a good question. So to that extent, at least, you would have multiple message queues that are created. The second thing that you could also do is like add a proxy service or add like a data layer in front of this, so that like you have information that is stored in some manner, because you want to create like, you want to prevent like, what I'm calling as like single point of failures. But yes, you do face the risk of like, if you don't have the message queues have that information sent, then you would return it. But the multiple ways that you can avoid this is like in these manners. I'm just going to outline it over here. One, write to disk in the message queue machine. That is one way that you can avoid this. The other way that you can do this is, you can have an in-memory cache that is sent behind while the comment service is like publishing this. Is like it goes over here and it also does this. So in that case, you have a failover over here. But again, like this also is like, what happens when this fails and what happens if this fails? You could have multiple backups of this, so that like at any given point in time, you're not relying on one set of machines, but this gets replicated. As soon as you have this information over here, you have replication that is built out so that like you have some sort of persistence layer. But if you look at like systems like Kafka and other like message queue systems, they do have built-in storage and built-in like replication mechanisms that help you avoid these kind of scenarios. But you can like solve this problem with like one, writing to in-memory caches at any given point in time and figuring out how the recovery should work. Because not only over here, you could have failures in this particular service as well, where it's read a comment, reads like a message from here, it fails. What do you do in that scenario? There should be a retry mechanism that goes back, figures out if like a message queue has been like completed or not, which means that you need to now worry about like, in order to make the machine persistent, you have acknowledgements that are being sent to like the message queue. So it only if like a message queue receives like 2 acknowledgements from 2 of its consumers does it mark a message as completed, so that like you know which message is the one that has been successfully completed in terms of like both writes and both like pushing to like the subscription service as well.
Okay. My one last question. So I see that you are doing read here, and then there is like this mapping here. So does it mean that like this read API is basically make an entry in this mapping, or like where does this mapping comes from?
Oh, so the mapping comes from as soon as like this particular client establishes a connection with like a machine in the subscription service. That is when the mapping is updated locally in like a machine within like the subscription service.
So there is a separate API, or is it like part of the read API?
Oh, it's part of the read API. So it's more or less like the handshake that is required to in order to establish a WebSocket connection. So it would be read. So let's say, for example, in terms of like a HTTP long polling or a connection over here, it would be a three-phase process where it would initially say read comment. It would send an acknowledgement back in terms of like, yes, it's been completed. And then the client again reestablishes a connection. So that would be like three-phase process in terms of like whatever protocol requires in terms of like how many steps that is required. That is pretty much like what this read API is supposed to do.
Okay, so this mapping and connection ID or post ID, you are relying for the underlying HTTP protocol to actually build this and maintain this? Or like, how do you maintain this? Are you going to maintain this manually, or going to be relying on HTTP protocol to do it for you?
Oh, so this would be maintained as soon as like the third, like let's say there are three steps in terms of establishing connection. Like one is send intent. Now the load balancer sends like, okay, I've acknowledged your intent. Established connection. It's at the third stage when it says, okay, fine. The intent is acknowledged. The second one is acknowledgement from like our server side that yes, okay, now it seems like there are enough machines. You can now establish a connection. And in the third part of the handshake process is when this mapping gets created. And this mapping is created within the machine that is managing this. So what I mean by this is like the manual phase is what is throwing me off, but the manual, it's pretty much is like it's stored locally within the machine. Unless you meant manual in a very different manner.
Okay, so that stuff is stored locally. So this means that like, are you going to use long polling here or like a WebSocket here?
I
Because
would prefer
the first read and the second read is going to be different then, right?
yes, yeah. So I would prefer using a WebSocket connection mainly because let's say this read path over here, if the same client that is established like the read is also supposed to send like writes, then you would use the same WebSocket connection to send the information. Now in that piece, it's up to the load balancer to, or whatever abstraction that we place over here, to figure out like what is the type of information or what payload is being sent or what message is being sent. And based on that particular message, send it to either like the subscription service or like the common create service.
Okay. And I guess one last thing, we are a bit over time, but like I still don't quite get like what is this push service responsibility? Is it like to push down the information to the client, or like is it to kind of like do fanning out a particular comment into like multiple?
Oh, it's doing the fanning out, sir. The push service is purely for fanning out purposes. So as soon as the message queue sends a message out, so for example, when the create happens, this entire service responsibility is to figure out which machines have subscribed for which post IDs, and for each of those post IDs, send out like the events, push events.
Okay.
It's for the fan out service. That's pretty much what this responsibility of this push service is. Now, if you zoom out, there's always the scenario of like you have multiple data centers as well. So the other responsibility that this push services also have is like if there are no machines that are present that are subscribed to this particular post ID, then it sends the information to like another data center, the push service in another data center as well. Now there is of course latency questions and everything else that needs to be considered. But the idea behind this is that is like this service has two responsibilities of like fanning out like comments that are currently in subscription for the current data center, and also sending the payload to other data centers that would be needed to ensure that you're sending the comments to like everyone that is subscribed to like the particular post ID.
Okay. Let's talk about feedback. Give me a second. Let me just write this down. Okay. I think while I feel like you are technically quite strong here, but there are some critical pieces where, you know, that is missing as an L5 above, right? So I'm going to give you a weak no higher as M1 here. So let me elaborate here, right? So I think the core point here is that there are two core points here that basically qualifies an L5 to L6. The first one is that the question itself. Some of the question can only get you to L4. Some questions get you to L6. Some questions can get you to L7. Basically, it depends on the complexity of the problem. This question happens to be a question that can evaluate someone all the way from L5 to L8. Right. So the degree of complexity of these questions can vary depending on like who talks about it. The second thing here is that to get you to L5, let me while we are talking about that, let me also give you assessment, right? So in this particular question, I think you managed to answer that quite well, right? So I think like, I don't really mind in that sense to give you like an L6 level evaluations because you explain it quite well. And then like your data flow and then the schema and then like the component responsibilities, everything makes sense. It maps really well end to end, right? So I think that's well done, right? The second part about like being on the evaluations for people. So let me just drop you like the evaluations criteria here. Here we go. So for L4, basically like you just have to explain things correctly, right? For any question. For L5, you have to explain trade-offs, SQL, no SQL, cap theorem, the one that you mentioned, push versus pull, left rest versus SQL, sync versus asynchronous. So these things needs to be explicit, right? Why something needs to use SQL versus no SQL? Why do you use push versus pull, right? So a bunch of those stuff. And this, I feel, is the one that is lacking here, right? You did discuss about trade-offs, about, cap theorem, right? You discussed briefly about REST and GraphQL, but not really like pros and cons, right? Yeah. But for L5 here, it is very important that you not come up with just one solution. You have to come up with at least two. You have to talk about the pros and cons explicitly, and you have to decide why you choose one versus the others, right? So the cap theorem that you did is actually one good example, right? Even though you didn't really talk about the pros and cons, but you actually explained quite well. But for example, things that you can do here, right? SQL versus no SQL, right? You don't really need asset property here. You don't really need relational database. So possibly NoSQL is a good option here. Possibly, right? Other thing here is that like, because like you want to use message queue because you want to make sure, because it's okay to do eventual consistency. You want to use message queue to reduce the load of a particular write server, right? Whether write service, the write comment service, you want to reduce the load. That's why you are leaning to use asynchronous process to fan out the, the comments, right? But this means you have to explicitly say that there is an alternative solution, which is removing the message queue altogether, right? And say they're like, hey, this actually can be synchronous. This is the pros. This can be asynchronous by adding message queue here. This is the pros and this is cons. I decide to use message queue. Why? Right? And that's the level of L5, right? if you want to get to L6, this data, this pros and cons needs to go back to your numbers and non-functional requirement. For example, like because of I do eventual consistency, which is in my non-functional requirement, then it's actually okay to do asynchronous, right? Or for example, because I want the latency to be less than 100 milliseconds, then I cannot do pull, right? Because if I do pulling, like asking the server every single 100 milliseconds, it's going to be expensive on the bandwidth. So that's why I am leaning to use push, right? So the point here is less about like which one is better, which one is the correct one, but more about the thought process on like why you use push versus pull. That is dictated by your requirement. So making sure that that your choices is dictated by a requirement, like either that's by non-functional requirement or that's by your number requirement, right? That is the requirement to get you to L6, right? So this too is, I feel that is lacking from your discussion, right? Explicit trade-off and backing it up with your requirement. So that's the two things that I feel is very lacking for the particular discussion. And then everything else I feel is fine. And then here's the thing, right? I feel like you can actually call out. If I give you some hints and if I give you some directions during the interview, I feel like you can call that out, right? I think like you technically are savvy enough to understand some hints and say like, hey, you gotta solve the trade-off or whatever, right? But you didn't manage to do that because you spent too much time on the functional, non-functional, and numbers. You spent 20 minutes there instead of 10 minutes. That is actually the benchmark. So that's why I think what you have to do in terms of like how to get better during the interview, the first thing that you have to do is you need to manage your time better. And how to do that? The first, in my suggestion, is to, this one, number 3, right? So when you talk about functional requirement and non-functional requirement, right? Instead of like asking and clarifying to the interviewer every single point, right? You shoot ahead, right? You think what is, you just talk and write on what you think is correct. And then you give opportunity for the interviewer to, as a checkpoint. Hey, this is what I think. What do you think? Right. So instead of like one point one by one, right? You do clarification. You do it in one go. Why? Because you need to manage your time better. By giving like a checkpoints where like the interviewer can disrupt you and can direct you to the more correct direction versus like correcting it one by one. This is actually a more efficient way to do interviews. It's probably not as effective, but it's for sure more efficient, right? So you have to balance between like, is it more effective or is it more efficient? But like, this is just one tips to make you more efficient, right? Because again, the problem is here. I feel like this is the biggest problem. You spend 1/3 more than, you spend 10 minutes more than like what are you supposed to do. And 10 minutes is basically 1/3 of the interview time. Right? It's 30% of the interview time. You don't have that much time to waste. The second one is like, on non-functional requirement, instead of thinking about like what functional requirement do I need here, right? But you just memorize about like, okay, these are like 10 possible non-functional requirements. And you just say like, yeah, this is needed. No, this is not needed. Right? Just to give you an example, these are a few possibilities of non-functional requirement, right? This is not exhaustive, but this is good enough, right? There are 6 possibilities. You can think about like, okay, do I need reliability here? No, I don't need it. Scalability. Do I need to handle up and down traffic? Oh yeah, I might need to handle like, spike on traffic. Do I need security? Not really. Do I need the data to be stored forever? Yeah, the comment needs to be stored forever. What about latency? Right. So it's more about like yes and no question versus like, okay, what does this system need? Does that make sense? It's just like more like an efficiency play, less about like whether this is more effective. This is just a way for you to come up with non-functional requirement faster.
Got it. Yeah.
And non-functional requirement, what is important is not for you to list them out, right? What is important about non-functional requirement is to talk about the implication. So for example, latency 200 milliseconds. Why does it matter, right? Similarly, like when you talk about numbers, like you talk about like 3.2 gigabyte of storage on daily basis. Okay. cool information, but what is it for? What does it mean? Does it mean like I only need like one instance of, database to store everything, right? What does 40 million comments per day means globally? Like, does it mean like, I need to horizontally scale the system? Does it mean I have to use specific kind of database that is high throughput on write? That's basically like the reason why you want to talk about the non-functional requirement, right? To talk about the implication of them, not just listing them out that, hey, I know about this term, right? No, that's not the point. The point is that like, yeah, I know this term and I know what does it mean for the system. It means I have to choose SQL database. It means I have to use Cassandra because I need high throughput. It means I have to use push because I need low latency. It means I need to do, I need to protect my system under VPC because I need security, right? So those are what's important about non-functional requirements. And, it's very lightweight, right? When you talk about security, you just say like, yeah, I need security. It means I need to protect my system under VPC. It's super fast, under 10 seconds, right? But it is like the difference between L5 and L6. Sorry, yeah, L5 and L6, right? And finally, just another efficiency play. So the way that you explain here is like you talk about, okay, this is the API, and then this is the schema, and then let's talk about high-level design, right? So instead of doing that, what you can do, so let's go to whiteboard, is actually, while you talk, right, you start with high-level design, you start drawing it, right? You start with the flow, and then while you are talking about one flow, you say like, okay, by the way, this flow, this is the API, right? And then when you talk about like all the way to the persistence, hey, while on this particular read flow, this is the data schema. Why is this more efficient? Because like you can explain things end to end and you can just copy paste things end to end, right? So there is a difference between like talking about things section by section. Okay, now I'm going to talk about API. Okay, next about the schema. Okay, next about the high level design. You can actually explain it like in one flow, right? You talk about, okay, this is the flow for read. By the way, the API for read is this, and the schema that I'm going to use is this. Okay, let's continue about write. The API I'm going to use for write is this, and then I'm going to use the same database and the same schema for the write. This has been proven to be 20%, at least 20% more efficient in terms of like the timing compared to like explaining section by section. Again, efficiency play. Not about effectiveness, but efficiency play. I mean, some interviewer will be confused, but this is something that you have to call out earlier, saying like, hey, I'm going to explain things end to end. So, I'm going to explain API while I'm also talking about the flow, right?
Got it.
So, bear with me in terms of like, what will be discussed in the API, and bear with me about what's going to be discussed in the schema. So that is like some tips for you. But overall, I think technically you are quite savvy. So I don't think you need to, read books or like watch YouTube videos about, hey, what is CDN, what is like load balancer. I think, you are good enough, right? You just have to manage your time better and understand that like what you explain here right now is not sufficient to get you to M1 level because you don't talk about trade-off and you don't connect your discussion against numbers.
Got it. Yeah. It's more or less organization is where I need to work on more and more.
Yeah. But that's should be, once you are aware of the problem, it should be quite straightforward to fix. I think that's mainly it. One extra tips for you. I mean, I have like a lot of tips here that you can read yourself. But one minor extra tips for you is, in every single system design, you gotta start thinking about what the core puzzle is. So for this particular question, the core puzzle is basically like, how do you get the messages? How do you get the comments, right? And there are actually two solutions, right? You either pull or push. And this is like actually the most important trade-off that you have to talk about during the interview, which you didn't. You immediately say push, right?
Yes. Yes.
You should have talked about the alternative.
The push
Pull
versus pull.
is not necessarily going to be wrong, by the way. But you gotta, if you think this is pull is wrong, you gotta tell me why it's wrong.
Got it.
Yeah. And that core puzzle is the most important trade-off that you have to make. So if you cannot come up with other trade-offs, like you don't want to talk about SQL versus NoSQL, REST API, GraphQL, if you don't have time to do that, at least just make this one trade-off about the core puzzle.
Got it. Yeah. I think there's.
Core puzzle. Okay. I think that's all my feedback. And we are a little bit over time. Any question do you have for me?
Oh, nothing much. So the only thing was, what does core puzzle mean?
Oh, the one that I just mentioned to you.
Yeah.
Basically, like if you think about like system design, right? Everything will kind of look the same, right? Like a client talking to load balancer, talking to API gateway, and then talking to some services, and then talking to like some database. Maybe you sprinkle in, you know, queuing system or cache here and there, right? But between one system design and the others, there is going to be like one core problem that we want you to solve, right?
Mm-hmm.
That's the core puzzle. Like, for example, in this question, the core puzzle is like, how do I actually get the messages, right?
Yes.
I don't really care how do you store it, right? Because it's going to be the same between like other, it's going to store either in SQL or SQL database. Sure, I don't care. But like, what is interesting is about how do you actually store the data? Like, how do you actually get the comments live, right? Let me give you another example, right? Say I want you to build a system about, storing and serving images on Instagram, right? Then the core puzzle is basically, hey, how do I serve the images to you in multiple resolution, right? How do I make sure that like, the image is not going to be too big? If it's too big, my low-end phone is going to crash, right? But if it's too small, then like, I'm going to see the certain image, right? And the trade-off here is going to be two, right? I can try to make multiple cache image at the beginning when I write it to the database, and I only fetch accordingly, or I can try to download on the fly and try to change the resolution on the fly, right? There is the pros and cons between the solutions, right? But do you understand that, like, this is like the most important part about, the storing the image for Instagram, for example, right? And this is the core puzzle, essentially.
Got it. Okay, it's basically the core problem that I need to solve for. I think, yeah.
Exactly.
Yeah.
Exactly. Giving another example, matching between like Uber driver and their rider, right?
Mm-hmm.
What is the core problem here? Well, the core problem is the core puzzle is like, how do I query efficiently, right? How do I match and query efficiently for a given like geographical radius, right? I need to know like which driver is actually in this area, and I want to map them against like this user, right? And the solution, there are many things. You can use like full table scan, which is not efficient. You can use geohash. You can use quadtree, and many other ways to do it. But that's the trade-off that we have to talk about.
Got it. Yeah, no, that makes perfect sense.
So typically, you will know what the core puzzle is the moment you listen to the problem, right? At least you will have some gut feeling about it. Like, okay, this is like what needs to be solved here. Like, the API, data schema, those two are not so important. Like those are like just generic system design.
Got it. But as long as like at least at like a E6, E5 level, it's about focusing on the core problem and you solving it or getting to solving it as quickly. Got it.
That is correct. Mm-hmm.
All right. I think this is super useful. Thank you so much.
Okay. Any other last question before we end the session?
Yeah, no, this is about it. Thank you again.
Oh, all right, cool. Good luck on the interview, man. Yeah.
Yeah. Bye.